Okay, so today we're going to talk about log functions, and we're going to write equivalent forms for exponential and logarithmic functions. So the first thing we want to know is, what is a logarithm? So it's going to be an exponent to which a specified base is raised to obtain a given value. So basically it's just a relationship between an exponent and a base depending on a value that we're given. So you can write any log equation as an exponential equation and vice versa. So this is the relationship in this box here. I'll write it in this marker too so you can see it a little bit better. So this is the log, and listen to how I pronounce it. This is log base b of y equals x. Okay, so log base b of y equals x, and that is going to be the same thing as this equation, b to the x power equals y. Which one of these is exponential? The one on the left or the one on the right? The one on the right. Okay, Taylor, how can you tell? Yeah, right, exactly. It's because of the x is the exponent, right? Okay, so let's talk about what these mean here. So the x value, this is going to be the number that the log equals. That's what I have on the side. Your b value is the base. Y is going to be the number you are taking the log of. Okay, so I'm taking the log of this number. Okay, and then I just wrote out for you again how you would say that. So this is log base b of y equals x. And this one is going to be b to the power of x equals y. Okay, so the way you say this is log base b of y equals x. This is b to the power of x equals y. Okay, and then for this equation, b is the base, x is the exponent, y is going to be the number the exponential equation equals. Okay, so whatever your exponential equation produces, that's what it'll equal. Okay, so I'm going to show you an example. Okay, so I'm going to give you the log form. So log base 2 of 8 equals 3, and we're going to try to write it in exponential form. Do some of you think you can do that using just this example here? Can you look at the positions and see if you can put it in the correct order? How many of you say, yeah, I can do that? One of you? All right. Okay, good. Okay, so did some of you try it? Yeah. Okay. Taylor, you want to tell me what you wrote?
8 to the second power equals 3.
Okay, so you have some good elements there. So see how you have the base here for the log is b?
Yeah.
Okay, so what's my base of this log?
2.
Yep, so whatever's here is going to be here as your base.
So it's 2, and then the 8 is the x. Wait.
I got it.
I don't know.
Okay, go ahead, Kylie. What do you think?
2 to the third equals 8.
Yes, good. Okay, and then can you also see that this is a great true statement? Because doesn't 2 to the third power equals 8? Yeah, right? And Taylor, I do appreciate your participation. I do. Okay, so, but Taylor, will you tell me again what you said first?
I said the 8 to 2.
Oh yeah, equals 3, right? Okay, no, this is really good. So like when you get to a test or something, we would know that this can't be it because 8 squared is what? Don't laugh. You guys, some of you guys are going to be doing the same thing. Okay, so this is a great way to check. Oh, is this equal? Okay. So another way that we've talked about doing it is I said, oh, we can think of it as the base answer exponent, and my students were like, oh, it's bay. So if you have the log form, BAE, Okay, base, answer, exponent. Okay, so 2 is your base, 3 is the exponent, 8 is the answer. So don't forget about your bay. Okay, logs are your bay now. Garrett's groaning back here. All right, and so example 1, write each exponential equation in log form. So see how this arrow goes both ways? Yes, Miss Whipple, we see it. Okay. All right, so that means not only could you start with a log and go to an exponential form, but you could start with exponential form and go towards the log. So that's what we're going to do for these. So for this, I have 3 to the 5th equals 243. Now for bay, that has to be in our log form. What I usually do is start with the base. Okay, so Arundi, what's my base in this one here? 5 is going to be the exponent. So the base is always what's attached to the exponent. Yeah, so it'll be 3. So when I start my log is going to be log base 3 of 243 equals 5. Okay, and like I said earlier, remember this is going to be, when we start to evaluate logs, I'm going to show you how these cancel out and equal 5. But for now, we're just going to focus on getting the form down. Okay, so I want you guys to try the rest of them. Good, some of you already did. Alex, you want to tell me what we got for B? Or Alex D? Or Alex Dirksen?
Log base 10 times 1, 0.
Okay, so good, except I'm just going to correct you, just something small. So it'll be log base 10 of 1, just not times 1. And yes, now log base 10 is actually special. So log base 10 is called the common log, which you guys don't know this yet, so this is something new. So if you have log base 10 of 1 equals 0, you can actually just write the log of 1 equals 0. And anytime you have a log and you can't see the base is going to be 10. And you guys may have noticed a log button on your calculator. That has a base of 10. Okay, so log base 10 and just regular old log where you can't see a base are the exact same thing. Okay, so this is called the common log. The common log has a base of 10. The common log has a base of, okay, we'll try that one more time with more participation. The common log has a base of 10. Yo, I love it. Okay, so for C, let's see how we did. See what I did there? All right, so log of 10,000 equals 4. So again, our log was base 10, and I don't need to write the base 10 because it is the common log. All right, Taylor, you want to give D a go for me? Tell me what you got.
Log 6.
Log base 6.
1, 6 equals -1.
Okay, good. Log base 6 of 1, 6 equals -1. Alex Taylor, you want to try E for me?
Log 8 times B.
Okay, so it's log, and then what did you say your base was?
A.
Okay, so log base A of
C.
equals B. All right, okay, and we'll practice saying that as we go on. What's that? I can't hear you. Is it not school appropriate?
No, it's the introduction to the B movie.
Oh. I haven't seen the B movie.
Don't ever
Don't.
watch it. Don't.
Don't?
When you're a
Don't.
kid, it's okay.
Oh.
Once you grow up, you realize what is wrong.
There's this video where every time they say B, it's like 10 times faster. It takes the entire movie to like.
How about we be studious and do A through E
The
here?
original video is every time they say B, it adds a multiplier. So it goes 1, 2, 3, 4, 5, 6.
Okay, so finish those first. Horrible. Okay, so example 2, when you're writing each log equation in exponential form, Okay, that's when you can use your base. Okay, and then so once you finish that, just check with your elbow partner.
I don't have a partner.
Tim needs you.
Hey, partner.
I want to be your elbow partner.
Yeah, you do. Come here often.
Good. Okay, so remember, your statement should also be true, and you have a lot of these on your power sheet. So like 2 to the 9th, can you guys check that on your power sheet?
3512.
And make sure it equals 512. Okay, so I want you to check yours. Check yours and also check your elbow partners with mine above. Okay. Now remember the negative here, right? 4 to the negative 2 is going to be 1 over 16 because it's 1 over 4 squared. Okay? And then so b to the 0 is 1. Why do we know that b to the 0 has to be 1? Good. Anything to the 0 power is 1. Remember we wrote that on our chart yesterday. Okay, so now we have some special properties that we want to talk about. So the first one is log base b of b. So whenever the base is the same thing as what the log is of, it's going to equal 1. But that makes sense, right? Because b to the first power is going to be b. Anything to the first power is going to be itself. Okay, so that's what the first law is telling us, that anything raised to the first power is itself. That's why log base b of b is 1. Now, if you have the log of 1, okay, the log base b of 1 is going to equal 0 because anything to the 0 power is going to be 1. And then the last one, we actually already mentioned this, but that's going to be your log with the base of 10. And your log with the base of 10 is just going to be the log of x. Okay, so we're just going to go over some examples with actual numbers. So instead of thinking of it as b's, we're going to think of it as 2. So log base 2 of 2 is 1. Yep, 2 to the first equals 2. Log base 4 of 1 equals 0. Yep, 4 to the 0 equals 1. And then log base 10 of 6 is going to equal the same thing as the log of 6. So when I tell you that a log is the relationship between the exponents and the powers, this is how the log is related to the exponential function. Okay, so that's what we're going to keep practicing. All right, and then we can flip it over. Okay, so we're going to evaluate using mental math. So, i.e., put those calculators down, but you can use your power chart. Okay, so when you have your test, you're going to have your test in 2 parts. One part will be a calculator, and then the bigger part is going to be a no calculator. Not for a little bit. Like 4-1 or no. The next one will be 4-3, 4-4, 4-5.
I need to see the bottom of that.
Oh, this one?
Yeah.
Yeah, log base 2 of 2 equals 1, and then 2 to the first equals 2. All right, and then we're going to evaluate using mental math here. So I'm going to give you the problem. Okay, so I have log base 5 of 125. Okay, and I'm actually going to show you 2 different ways you can think about this, and then you can choose which way you want to do on your homework. Okay, so notice that it doesn't equal anything because we're just evaluating. So if you want to think of this as equal to something, you can think of it as equal to x. Okay, so it's like we're doing log base 5 of 125 equals x, and we have to solve for x. So now that it's in this form, do you guys think you could rewrite that in exponential form? Okay, so let's think about what our base is. Okay, actually, Grace, do you think you can tell me what your equation is in exponential form for this?
5.
Yep, good. 5's your base.
5.
No?
125.
No?
10.
Another way I remember this, another way I remember this besides bay is I think of it equals the exponent. So see how it equals x?
Yeah.
So that means x has to be my exponent, and it's going to equal 125.
I did that right.
Okay, so then this is what you want to think about. 5 to what power is 125? Okay, so you can use your power chart. Okay, so 5 to what power? Now, if you're using your power chart, you aren't going to be looking in a column. What are you looking for?
The 5.
Yeah, you're looking for the 5, right? Well, we know 5 squared is what? 25. Okay, so 5 cubed? 125. So then if we solve this, our answer would be x equals 3. Okay, and it's x equals 3 because 5 cubed, or 5 times 5 times 5, is 125. Okay, I think this is the way that you're going to like to do this a little bit better, but I want to show you the other way so you understand how the log function works. So another way you can think of this is, oh, I know that 125 is 5 to the third power. So what you can do is rewrite it. So instead of 125, if you write 5 to the third, then do you notice that these two are the same, the log base 5 and the 5?
Yeah.
Okay, and these two equations are inverses. What do inverses do to each other? Yeah, they're going to cancel each other out. They're going to undo the other one. So if these cancel out, log base 5 and 5, what am I going to be left with? 3. Okay, so you can show your work either one of those ways. You can either write out your exponential one, or you can show me that you cancel those out. Okay, so you just have to show me one of those two steps. Okay, so I want you to do B, log base 2 of 16, and then you can choose which way you want to write it out. You don't have to write out both unless you want to. I'm going to continue writing out both. Oh, that was so weird. No. Okay, good. Good. Okay, so what did you guys get for x? 4.
How'd you know? Yeah.
No, it does not. Because we can cater to you. Oh, yeah, absolutely. In fact, we're working on building up, like, some of the skills that you may have missed. Well, no. Most people know that. Okay, so you could do either one of these. Did you guys have a question on this one, on B?
No.
Okay. Okay, so then let's try these. Well, actually, we'll do this one together.
Log 10.
Right, good. Okay, so where's the log? And then Grace, how do you know log 10?
Because it's the common one.
Exactly, it's the common log. Good. So if you don't see one, it's going to be log base 10. So I actually might rewrite it like that first, so that you know that it's the log base 10. Okay, so then we're trying to figure out 10 to what power equals 0.01. And I don't know about you guys, but that doesn't really come easily to me if I'm trying to convert to a decimal. So I think it's a lot easier if we put that decimal in fraction form. So do you guys remember what place value this is? Good, the hundredths. So this is 1, no, because this is 1, right? So it's 1 over what?
100.
Yeah, so it's 1 over 100. Now from here, this is where we have to remember a few things. First of all, do you guys notice how there's a 1 on the top?
Yeah.
So then what kind of answer am I most likely going to have? Yes, very good. It'll be negative. Yes, perfect. Okay, so Kylie, can you tell me why it is 10 to the negative 2?
Because 10 squared is 100.
Yep.
So you have to take it 100.
Perfect. Okay, so because 10 squared is 100, and with a negative, we have to put it over 1, we know that our answer is going to be negative 2. Okay, so one thing that can kind of help you know when it's a negative is if you see what?
A fraction.
A fraction with the 1 over it, or yeah, if you have a small decimal. So like with this one, I know. Yeah, do you guys remember that? Yeah, you can. So this is the tenths. What this place is the? And then the 10,000s? 100,000. Okay, so yeah. So it is 1 over 100,000. And I'm also going to show you another way you can think of this. But so 10 to what power is 100,000? So if you think of where the 10 is, you can think about how many places you have to move the decimal. So if you move your decimal 1, 2, 3, 4, 5 to get to the end of this, this is going to be negative 5.
That's so much easier.
That, yeah. Okay, so you can check 1 times 10 to the negative 5th would be 1, 2, 3, 4, 5, and there we go. Yep. So does that make sense too with the first one for part C? Yeah, because we move it 1, 2. And you guys know when to stop because it's just after whatever number you have there at the end. Okay. All right, let's try this one. Okay, so our first step is setting it up. Gabe, will you tell me what my setup's going to be? Just, yep, like the first step. Uh-huh. Okay, yep, okay. Okay, and then let's do the exponential one now. So from there, yep, so 25 to the power of x equals 0.04, good. Okay, and then did some of you already turn this into a fraction? Okay, yeah, Garrett, what's this fraction going to be?
0.04.
Well, but what's it going to be as a fraction? So what place is it in?
Hundreds, like 4 100s.
Yep, exactly.
1/25.
Good. Okay, so 4 over 100, which is going to reduce to 1 over 25. Okay, Alex Dale, do you think you know what my answer is going to be?
Not really.
Yeah. So you see the relationship between the 25 is here and the 25 is here?
Yeah.
Okay, so Alex, 25 to what power is 25?
1.
Okay, to the first, good. Now, do you see here that it's over 1? So anytime you have 1 on the top, do you remember what we said that was?
A reverse negative.
A negative, right? Okay, so then x is just going to be what? Nope, you got it? Okay, good. X is going to be -1. Good. How many of you got that? Great. Good. Because you're thinking of a B movie. Okay, so then let's try this one. Yeah, you guys are doing really well. Get writing over there. Yeah, keep it as the one bit. So what's x going to be from there?
1.
Wow. Yeah, which one? Yeah. Yep. Okay, Marisha, what'd you get?
-1.
Good. Okay, so this one was very similar to the last one. Okay, where you notice, hey, if this is 5 and this is 5, the only thing I have here is the 1 on top. I know I'm going to have a negative. Alright, and then I have log base 4 of 1 over 64. Okay, so Kaylin, what do I know right away when I set this up?
It's going to be a negative number.
Good, it's going to be a negative number. So are we all on the same page that we know this is going to be a negative now?
Yeah.
Okay, Alex Dale, how do we know this is going to be a negative? It's a fraction, yep, it's over 1, right? Okay, so, Grace, you know what we're going to ask ourselves to try to solve this? Well, we already have the fraction, so what we're going to do is we're going to ask ourselves, 4 to what power is 64? Okay, so we're going to find that out. We can use our power chart, right? We already know 4 squared, right? What's 4 squared? 16, right? Okay, so look at our power chart. Okay, so after 4 squared, let's look at what? 4 to the...
Third.
Yeah, okay, what's 4 to the third?
Well, I'm not sure because.
Because you didn't do your homework. I gotcha. Okay. Around, did you know what 4 to the third is? You have your power chart?
No, wait. It's 64.
Okay, good. So it is 64. Okay, so then, Around, did you know what our final answer is going to be for x?
Maybe you have to tell us because she has her power chart.
No. Okay, so we said 4 to the third is 64, right?
Yeah.
Okay, so we're close to that. We just have to get the 1 over it. So to get the 1 over it, instead of doing 4 to the third, we're going to do 4 to the... So what makes the 1 over it? What kind of number? Yeah, so anytime we have a negative, we'll put the 1 over it. So you said that it was going to be 3. So x is going to be -3. So let's go over why. Because 4 cubed is going to be 64. So if we have 4 to the -3, that becomes 1 over 4 cubed. And then do most of you guys see that on your power chart? So whenever you have like a fraction, for a minute, we're kind of ignoring that. What this is telling us is our answer is going to be negative, and then we can use our chart to see, 4 to what power is going to be 64. Okay? All right, so I'm going to give you time to work on your homework. So this is no calculator, but you can use your power chart. Now, obviously, I can't monitor you at home. I'm just telling you that your quiz is going to be no calculator. So if you don't practice this using your power chart, then you're kind of hurting yourself for your calculator.